Welcome to today's BA video. Myself S. Gunanandani, Department of Computer Science and Engineering in SA Engineering College. My topic is about nonlinear data structures in graph. Here, introduction of graph, types of graphs and fundamental of graph algorithm and graph data structures and implementation and its application. Now, what is graph? A graph is connected nodes and edges it may be a directed or undirected or weighted or unweighted. It may be cyclic or uncyclic, and it contains node with adjacent degrees. Types of graph representation. It contains adjacent matrix, edges may be connected with matrix side, may be I and J. If the edges are between vertex I and J, it contains 1, otherwise 0. Example, the edges 0 and 0 is 0, 1 and 1 is 0, 2 and 2 is 0, others contains remains 1. This is adjacent matrix. Next, adjacency list. It contains 0, 1. The weighted path moves to 1, 2, and 1 moves to 0, 2, and 2 moves to 1 or 0. We represent adjacent list in this type. And breadth first and depth first search. In breadth first search, a queue, it explores the vertices in all possible unweighted graphs. It contains, sir, இது mark off பண்ணிருக்கேன், but diagram வரல.
Next is what?
It may be all possible ways to design a graph. In each and every vertices, the graph contains all possible ways. The input as 1, 2, 0, 2, 0, 1, 3, 4 or 2. It may be the first node is 0. It contains 1 or 2. And then move to 3, then 4. It may be weighted or unweighted. It moves the whole path with all different ways. This is breadth first search. In depth first search, it allows a deep meaning in all possible ways. For example, in network flows, social media networks, 1, 2, 3, 4 and 0. This is depth first search. The output for breadth first search and depth first search are also 0, 1, 2, 3 and 4. The shortest path algorithm, it contains which way is shortest and which way along to easily move to the way. The types are discrete algorithm, Bellman-Ford algorithm and Floody-Warshall algorithm. The weighted path or unweighted path, which is move easily or which is cost minimum, like that we weighted. And minimum spanning tree, which cost a very minimum. Here the minimum cost A to B and B to D. Here the example, the minimum cost span is weighted to 1, 2, 3. We taken as 1, 2 and 3 alone. Next, the graphic cycle deduction. It contains 3 parts. One is undirected, another one is directed. Cyclic graph undirected and cyclic undirected graph. Mainly we using a graph application in social media network like Facebook and Twitter. We take as an example Facebook as a weighted graph and Twitter is an unweighted graph. And navigation in transport, we using GPS location to track easily with minimum cost or minimum distance detection. And web page ranking, in a Google rank along n number of searches, we need only 1 or 2 searches. It is an example for minimum spanning tree. And computer networks with the routers protocols, how much cost is defined, and circuit design and OS. These are the real-time application in a graph structure. Here some example video questions for GATE in previous question paper. Let G is a directed graph and the depth first search, a spanning tree in G that is rooted at a vertex, and suppose T is also the breadth first search, the tree G is rooted at V. Which of the following statement is true? Here the answer, the options are, there is no back edges with the G, but all edges are containing with 3, and there is no forwarded edges. It also wrong. It also contain edges. The right answer is the cross edge with respect with 3. Here considering a spanning tree, which is the shortest path in the sequence. The all sequence belongs to first options A, B. Now the right option is D, 1, 3, 4 only. Here the maximum value in a such edge between the nodes B and C is including every minimum spanning tree. The given graph is the x value of x. Here we see the example, the opposite matrix 7 and 8 here, the adjacent matrix. Here 6, the minimum value is below 6. X is less than 6, so the answer is 5. Which of the following statement is true for simple undirect graph? The number of odd degree vertices is even, sum of degree of all vertices is even. The both answers are true. The answer is both P and Q. The number of distinct minimum weighted spanning tree of following graph. Here the graph contains 3 cyclic graph. G to B, G to A and G to F. That means 3 cyclic into another 3 cyclic. The answer is 9. 3 into 3 cross 9 the graph. Next, consider a direct acyclic graph DAG, which is the following true regarding the topological order. Direct acyclic graph is exactly one topology order. It cannot have any topological order, at least one topological order. At least number of ordering depends on only number of edges. The right answer is C. At least it contains only one topological order. Thank you. Thank you. We will continue in next section. Thank you so much.